Hello everybody. Here we are for chapter 14, section 3. We're going to talk about the environmental effects of using non-renewable mineral resources. I mean, it's somewhat redundant. Mineral resources just aren't renewable. It takes so long, but here we go. When we talk about extracting minerals from the Earth's crust, the crust is the only place we can get it. There's plenty in the mantle, but we can't get that far down. So we're mining them out of the crust. And then we're converting them into useful products. That's the name of the game, right? We don't really care about copper. We care what copper can do for us. Now, in order to do that, obviously we're disturbing the land. We're digging it up or rooting it out, so messing up whatever's on top of it. Since we're removing vegetation and digging things up, we are eroding the soil. It's being exposed to the elements, water, wind, what have you. We produce really large amounts of solid waste. We're trying to dig this stuff up, and all we want is this tiny little bit of copper out of this whole big chunk of rock. And that big chunk of rock is now just solid waste. And we're polluting the air, all the dust, various chemicals, things going up into the air, things leach down into the water and the soil. So there's a pretty heavy environmental cost when it comes to mining or getting these minerals out of the ground. Let's talk about some of these harmful environmental effects, if you will. Now, metal, we have metal and non-metal minerals. Just right now, we'll talk about metal. Metals have a life cycle, if you will. Now, the picture I'm kind of putting up here kind of goes through this process, if you will. And we can sort of break it down into two chunks, in a sense. Getting it out of the ground and ready to go, and then kind of into the product end. So just as we look at the pictures, well, we have to mine for it, right? We got to dig it out of the ground in some shape, form, or fashion. So we're disturbing the ground, we're pulling it out, we're getting the ore. And once we have the ore out of the ground, this is rock with substantial amounts of copper, gold, tin, whatever we're after. Then we have to separate the ore from the other stuff. They chunk the waste back out to the side. We take the ore and then we smelt it. Now there are different ways to go about it. Smelting it, where we melt it down, is just one of the more common, especially if we're talking about iron or some of these other products. We melt it down so we can get the iron off. So we smelt it to purify it, and then we'll melt it down into whatever shape or form we want. In this case, we're making a car. And then we use the car. Now, as we use the car, there's a part that we can recycle it. We might reuse it. Let's say you finish with your car, you may resell it to someone else. Ultimately, it could wind up being recycled, and then eventually there's throwing it away. We discard it. So we can use things for a while, but eventually it's going like a wrecked car, and it may just be tossed or put out to junk until it rusts, and it's really no good to anybody. But everything has this cycle. We pull it out of the ground, we use it, we can reuse it for a while, but eventually it just sort of becomes junk, and then we kind of have to start the process over and go get new metal. Now, when we talk about the environmental impacts of any particular ore, whether it's copper, tin, gold, what have you, platinum maybe, well, there are different environmental impacts, and this depends on the ore's grade. The higher the grade, the less ground we have to disturb to get what we want. Once again, when it comes to gold, gone are the days we've got a big fat nugget here. It just doesn't happen anymore. This idea of finding a nice big thick vein of gold or copper is very unusual. We've got the easy stuff out. But the heavier amount of metal in the ore, or the higher the grade, the less disturbing we have to do to the ground. It's easier to get it out. So depending on the percentage of the metal content, we do less disturbing. Now let's talk about some of the most common. Surface mining. This is where the ore is very close to the surface, whatever it is we're after. The picture I'm putting up here, you see that big mound? Well, that's not a mountain, that's a hill, and that is from surface mining. This is where the deposits are pretty shallow. Now this particular one we're looking at is a potassium mine. We're mining out potassium. We use this in fertilizer, a lot of various things. So they are digging it up out of the ground, and this is the solid waste we talked about. We remove the shallow deposits, and the overburden, this is the stuff that's on top of what we want. So we have ground and dirt, we gotta get rid of that to get down to where the ore is. And all we do is we scrape all that overburden off to the side, and then we dig down for whatever it is we're after. But this overburden just gets deposited into spoils, big heaps and mounds of the material that we don't want in order to get to the material that we do want. And this is just waste material. Once again, it's been dug up, re-rooted, then it rains, it erodes, and anything that's in that leaches back out into the ground. Most of the stuff we're trying to get, but some traces are still there, and other chemicals work their way into the ground, water the local streams, what have you. Another one, once again, if things are near the surface, is open pit mining. Now the one you're looking at here, this is a copper mine. Now we have open pit mining for copper, for gold, for diamonds, lots of various things. But if it's reasonably close to the surface, we just begin digging a big hole. Now it's hard to get a perspective of that, but if that was a stadium, you could fit hundreds of thousands of people in it. These things are massive. To try and give you some sense of scale, those rings that you see, those are like roads, highways, where the trucks, the big like dump trucks, drive down and around to the bottom and get the ore and drive up and around and back. And usually 2 trucks can fit on these things. They're like a big 2 to 4 lane highway circling that thing. These are huge, just big open pits. We just get what we can, we remove it, and we remove it, and we remove it, and we're just left with a ginormous hole. But once again, open pit mining. Another one is strip mining. Now the picture here of this strip mining is for gold, area strip mining. So we kind of strip off the area. It's not real deep down, it's more shallow, and we just keep stripping off the surface of it. So we take entire swaths and tracts of land, and we just keep digging and rooting down and getting out what we can. We refer to this as strip mining. We're just stripping all the vegetation, everything off the area, and digging down into the reasonably shallow areas to grab the goods. In this case, we happen to be looking at a gold mine. Once again, some gold mines are pit mines. This is a strip mine. We strip mine for coal, we strip mine for copper, anything that we can. We use whichever method is easiest, most cost effective to get the ore. Another one that we use is contour strip mining. Now the picture we're looking up here is of a coal mine. So coal forms under the ground. It tends to form in these kind of layers. Remember, coal, fossil fuels. This is plant matter that's been compacted by time. And it gets pushed up in mountains, so it'll be in these layers. Well, in mountainous or very hilly, we do this contour strip mining. You can see we pull a bit of the way out. We get rid of this overburden. The overburden is the stuff we don't want. Could be rock or dirt. So we strip off all the vegetation, we push that away. Typically what we do is we contour. We take it all out of this area, and then we go to the next area and we just fill this in with it. So we dig out the mine here, we get rid of all the coal, there's no more coal, and we go to the next area and we contour and we strip it off and push it down onto here, and we just keep moving it across the mountain. The contour strip mining, we just pull it off of one area, push it down into the next, go to the next area, push it off, and we get these kind of high walls we talk about. Once again, we get a lot of erosion, landslides, all kinds of things happen from it. Another one, kind of my personal favorite to hate, I don't know if that's the right one, the one I like the least, mountain topping. We do this is a picture out in West Virginia. We do this in a lot of coal. We literally just go in, you take a mountain, we put explosives all down underneath it and blow up the top of the mountain and just push the rock off down into the valley below and strip out the coal. This is incredibly destructive. Once again, coal mines are supposed to return it to what it looks like. Well, guys, once you blow the top of a mountain off, you can't take that dirt and stick it back up there and it'd be a mountain. It was rock and solid rock. A mountain topping is incredibly destructive. But once again, we want our coal. We need our coal to run our electricity, lights, air conditioning, etc. And they're still largely dependent on fossil fuels, coal being a huge one. And it's this mountain topping. They literally chop off the mountains, dig it down, push everything off. When they're done, they're supposed to restore it, but this one's incredibly difficult to do with that. Now, if what we're after is not near the surface, it's real deep underground, then we go into subsurface mining. A lot of times when we think about mining or people going to mine shafts, this is what we picture, where they're going down deep underground mining, but it's subsurface mining. A lot of mining's happening at the surface. Strip mining, open pit. You know, you're out in the open air, if you will. You're digging down, but it's still sky up above you. Subsurface mining, you're going down in a hole. These are really deep deposits. Typically, this is like 50 meters or more below the surface of the earth. Sometimes getting really deep, 200 meters or more. Now, a lot of problems with this. The picture you can see is what we do. We drill a mine shaft. So we go down and then we mine out sideways. So we get down to the coal, if you will. Coal and salt are ones that we do a lot of shaft mining. We drop a shaft and then we mine out this whole area. So you kind of carve out these holes. And a lot of times what we'll do is we'll leave pillars in place. So you'll leave this little chunk of coal or salt, whatever it is, and you'll mine all around it. And then the last thing you do is you take out the pillars. Well, one of the problems with these is subsistence. The ground caves in. We hear about mines collapsing, cave-ins. Well, this is what happens, right? We're deep underground and we're cutting out a big hole. Well, if we don't do it properly, the ground above can collapse and the mine collapses and fills in. Well, it's hazard for miners if they get trapped in there, but also it causes subsidence above and the ground caves in up above it. This can be particularly bad. All kinds of like pipelines and et cetera might be running under the surface near here because we're 200 meters down. A lot of stuff is up here more shallow. And if it all subsides, it disrupts all of that, whether it's roads, highways, piping, plumbing, you name it. Also, just hazards for the miners. They're deep underground. They're breathing in a lot of the toxic fumes. They're bringing in the coal dust. Fires can occur down here. It's incredibly dangerous because once a fire starts, it's almost remember, we're digging for coal. It burns. And if it catches on fire, it's almost impossible to put out. We can't get anything down there and the air comes down in through the shafts. And a lot of these places we're mining, we're using chemicals to extract the ore. Acids are very common. Sulfuric acid is one that we use a lot. We extract copper with it, put the sulfuric acid in, we get copper sulfate, then we can pull the copper out from the copper sulfate. And this acids can drain out of the mine, leak into the groundwater. In a few instances, we've had the backside of the mine. They didn't realize how close they were to the back wall. The back wall caved out and all the acid just leaked out down into the streams. So there's a lot of potential problems when we talk about this deep down mines. When we extract the ore by mining, we're going after the ore mineral, but there's a lot of waste material. Once again, we're digging it out and we're not only coming out with coal, we're coming out with coal and overburden. We're not just coming out with copper, we're coming out with copper ore. There's lots of other material. This waste material. Now, a lot of times we'll take it and we'll smelt it. We'll heat it up to the melting point of, let's say, iron, if we're going after iron. So we crush this rock up, we put it in the smelter, we heat it up to the melting point of iron, which is lower than the melting point of rock, and the iron begins to melt off, then we can pour it off. Well, in doing this, we're vaporizing a lot of materials, creating some toxic gas, and it can lead to air pollution, obviously. A lot of this leads to a lot of water pollution. We need a lot of water when it comes to mining to wash things off, brush them down, and all that water goes back out into just the environment. And in a lot of places, we have poverty-stricken miners. We have people going after gold, copper, tin, what have you, and these are kind of subsistence miners, if you will. In some of these less developed countries, they are going into forest wherever they can, and they're using just whatever means they can to extract the ore. And they are not concerned with the environment. They're using mercury, because you put in mercury, then you heat up the mercury and it extracts the gold from the ore. Well, when you're doing that, we're putting mercury into the ground. That mercury makes its way into the water supply, and people die from it. The people that live in the area come in and they catch the fish and they're getting mercury poison. They're breathing the air because they're heating it up to extract it out, and it's vaporizing into the air. So a lot of these practices in some less developed countries where there aren't as many restrictions about mining, and sometimes there are restrictions, but there's nobody out there policing people that are just doing it illegally. The mine you see here is an illegal gold mine. It's just there's nobody to really stop it. And a lot of times the practices are incredibly unhealthy for the people actually trying to go after these minerals and for everybody else that lives there. There's a lot of environmental hazards and a lot of things to think about when it does come to mining, going after the ore, but that does wrap it up for section 3. Come back with me next time and we'll try and look at ways that we can use mineral resources more sustainably. Because once again, in environmental science, sustainability is the name of the game. Take care, guys, and we'll see you next time.